Here are we going to talk about empirical relation between mean, median, and mode in comparison of the measures of central tendency. So the mean, median, and mode has the relation that for the normal skewed or distributive data, that is mode is equal to 3 median minus 2 mode. And these are the values. When they minus what we get, the comparison is that the numerical value of every score in the data set contributes towards mean, because mean depends on it, but not is the same for the median and mode. Single peak symmetrical distribution leads to mean is equal to median is equal to mode, but it is not naturally practical, so the values will be different. Now, point number 4. Point number 4 is if a population is not symmetrical, the mean, median, and mode, it will not be equal. Simple. The mean is affected by the presence of few extreme scores, while the median and mode are not, because mean is the one which is again and again repeated, the number which is again and again repeated and occur in the data. In the absence of the extreme value in data, the mean is preferred. Okay, the median is preferred if the center interest lies on the typical rather than the total score, and if the distribution is skewed. That is, distribution is skewed. Normally, it is identified, and the total score, that it is then not important because it can be any initial point or final point. The comparison further is the median is appropriate and mean cannot be computed directly if some score are missing. The mode is preferred only if the distribution is multi-model and multi-valued index is satisfactory. So the median is appropriate and mean cannot be computed directly. Simple, it is comparison of three of them. Then we go towards quartile. Quartile, the value that divides the set of the score into four parts: Q1, Q2, Q3, Q4. These Q1, the Q1 shows that it is the lower quartile and the Q3 is the upper quartile. The Q1 shows that the 25% scores are less than it, and 75% are less than the Q3. Now the Q1 formula is n plus 1 by 4 the score. Simple, the Q2 will be same formula, but 2 will be included in the formula outside the bracket. And for 3 also, here we go. Here we go for Q2, Q3. Yes, it is Q2 and Q3. The simple is the find. There is example to find the quartiles for the data. The data we arrange in array order, and there are total 20 numbers. So we are going to put them into formula. 20 number n is 20. 1 is the quartile, and 4 divided by 4. So it gives 5.25 the score. So the fifth score with half of more is then here added 2.5. So it means that the fifth plus 2.5 will be minus than the sixth score. So 26 is the fifth score, and 25 that here we get from the calculation is here added. This means the sixth score will get subtract the 5.25 score. So when it is subtracted, the 27 we get. Simple, the scores are put it in the formula. You can see that for quartile 3. I hope you are getting. It is easy but important concept to know. for examination point of view, because the book is damaged and page are also mopped, I think I can share. For the group data, these formula are the another example, and simple by putting these value. It is simple, but it is heavy in numbers to see them again and again. It is simple. I hope you are getting the concept. If you like my video, give it a thumbs up, share it with others, subscribe to my channel for more videos. The earlier videos are about the interpretation of the measurement scales, the mean, median, and mode, which is a central tendency. Now it is their empirical relation and comparison and quartiles. Next will be the percentiles, uh, frequency distribution. So thank you for watching.